Now we will consider the next architectural style that calls service-based architectural style. We are going from the most monolithic architectural style that is layered through the pipeline architectural style. Sometimes it calls pipe and filter architectural styles. It's the same. Then we already consider the microkernel architectural style that is a little bit more distributed, a little bit has higher modularity than comparing with layered architectural style, but still it is one of the monolithic architectural style. And now we move more in the modularity and start and the first architectural style from the distributed architectural styles is service-based architecture. So what it is, service-based architecture is actually the hybrid of the microservice architecture style and is considered one of the most pragmatic architectural styles, basically due to the flexibility. Although service-based architecture is a distributed architectural, it doesn't have the same level of complexity and cost as other distributed architecturals, such as, for example, microservices or event-driven architecture. That means that in some cases, maybe this one is more preferable choice. What is the topology? The basic topology of service-based architecture follows a distributed macro-layered structure. Consisting of a separately deployed user interface, separately deployed remote services, and monolithic database. So one more time, separate deployed services, separately deployed user interface, and monolithic, not distributed, but still monolithic database. This is a basic topology of service-based architecture style. Within this, so services within this architecture style are typically coarse-grained. So it means that they are designed in the mind of domain specific. So they are mainly domain services that are independent and separately deployed. So these services is independent and they can be deployed separately. Services are typically deployed in the same way as the monolithic application. So it can be packed inside of archives as ER for the Java or WAR file. And as such, do not require containerization. So it means no need to use Docker and wrap all of them as Docker images. So it can be delivered as archived. So one more time, how they can look like. This is separate services. That is domain specific, each of them, but still it is not required, as we will compare with microservice architecture Dockerization. So containerization, sorry. So no need to use, for example, Docker or other containerization tools to wrap it inside of the container. It can be delivered in the same way as you delivered the monolithic application as a layered, for example. So like this one is little layered services, which is designed specifically for some specific domain. So because the service typically share a single monolithic database, the number of services within the application context generally range between 4 till 12 services. So it's an average, maybe seven services. So it means for sure it depends on the specific project. But if you will compare with the microservice architecture, you will notice that the number of services, it should be much more less in service-based architecture than it can be exist in microservice architecture. But still they're domain-centric. What should you point the attention? That in the most cases, there is only one single instance of each domain service within a service-based architecture. However, you can still make some basic scalability, fault tolerance. So multiple instances of domain services can exist. It can be. So multiple instances of a service usually require some sort of load balancing capabilities between the user interface and domain services, so that the user interface can be directed to the health available instance. So you can load balance and scale some of the services, and so the user interface will switch the path from one service to another one to communicate with. Services are accessed remotely from a user interface using the remote access protocol. It's mostly we are talking about here about the REST, but still it can be SOAP. So even SOAP can be used as well as a REST. And API layer consisting of a proxy or gateway can be used to access services from the user interface. But in most cases, you will not find here any gateway. There will be the direct communication with such services. One of the most important thing is, yeah. By the way, I don't have pointer here. At least I suppose you can follow for the mouse, for the pointer from the mouse. Yeah. So one important aspect of service-based architecture is that it typically uses a centrally shared database. So this one database is centrally shared between all of the services. This is one of the key point of service-based architecture. But what it means? So it means that services will make the SQL queries, and it will execute it in the same way as it is executed in a traditional style with a monolithic layered architecture. Will it work if the number of services is not so high? And in our approach, it is. So generally, it can be. So database connection are not usually an issue in a service-based architecture. But what can be the issue, where your concern should be, is that what will happen in case if database will change. So if the database will change the schema, then it will affect all of the services, and it will require some actions from this perspective. It means that is there any options? We'll take a look. But first, this is the main topology. It doesn't mean that there is no options or there is no variance of service-based architecture, and you should do exactly in this way. Of course, not. There can be some variance here. Yeah. So this is just about that information that I already told you. You can just quickly take a look, and let's move to the next point, is that many topology variants exist within the service-based architecture styles, making this perhaps one of the most flexible architecture styles. And if you will know these variants, these options, then first of all, you will be able to recognize, is it a service-based architecture style or something else, or maybe there is no architecture style at all, or maybe some mixing. And from another perspective, if you will know that there is a variance, then you can apply this variance of architectural styles. Maybe some of them is better suited for your particular case. Here is one of them. For example, domain-based user interface. A user interface can be split into different deployable units specifically to the domain. For example, here we'll have the user interface, which will be designed for the users, and here we will have the admin user interface that will use another set of services to work with. But still, they will use shared database, so it will be still a service-based architecture. Either any other options? Yes, it is. For example, the user interface can be split into the one more time. You can have 4 user interfaces. Each of them will communicate with separate service, a service-based user interface, it calls. So it also service-based architecture styles. If you will notice a point like something like this, and you will have, for example, 4 front-end services, each of them will communicate with separate backend services, but still each backend service will work with a single shared database. It will be service-based architecture style. Actually, the similar opportunities may exist to break even a single monolithic database into separate databases. So you can even create another one database that will be that, for example, this will work with this service. User interface will be this, like one single deployable unit that it will work with different services, and some of the services will have separate database. So similar opportunities may exist to break apart a single monolithic database into separate databases, even going as far as domain scope databases matching each domain services. So even if we will even split this database to each of the separate databases, it still will be service-based architecture. Because, but will it looks like microservice architecture style? Actually, it will. You can think that look, then it why it is service-based? It looks like microservice architecture style because we have separate services. Each of the services have separate databases. But keep in mind what is the number of these services, how well they are grained, what is granularity of these services, how the domain is divided, domain area is divided between services. And this will be the answer that is it microservice or is it service-based? Is it better sometimes to do like to separate as in service-based to make the services a little bit more like say they will cover more functionality? Sometimes yes, it will be better choice than use the microservice. Even if you will split the database to each of the components, and it will looks like this one. So this is service-based. My personal opinion is that in some particular cases, a lot of mistakes on the design is that instead of choosing this approach, it is the microservice architecture is chosen. This one is quite similar. It also distributed, but the number of benefits of quality attributes in this case can be better, or they are not better, not more, but it means they are more suitable. There is trade-off between each of them. In most cases, it is more suitable for particular case. But in this case, it is important to make sure that data in each separate database is not needed by another domain services before we will do this. If you have sure about this, keep going this way. This is the correct direction. So this avoids inter-service communication between domain services, which sometimes to definitely avoid with service-based architecture. And also the duplication of data between database. We have to always to remember high cohesion, low coupling. This is the basic thing that will bring us to the success instead of making to fail the project. And particularly this case can be one of the key to achieve this. What else? So it is also possible to add an API layer consisting of a reverse proxy or gateway between the user interface and services. So still you can put additional API level as a proxy or gateway in this communication, and in case of there will be high load for one service, you will be able to scale this service, and their request will go to their another one services that has less loading. So you will balance the ability to give the response. It's still the points. But what is important when we consider the service-based architecture is the granularity. This is one of the key points here. So because domain services is a service-based architecture are generally coarse-grained, each domain service is typically designed using the layered architecture style, consisting of an API facade layer, business layer, and, as you expect, persistence layer. So we will have facade layer, business logic, and presentation layer in each of the services. So each of the services can be considered as a part of small monolithic service, so small, not small, but let's say medium-sized service, which is based on the layered approach by under the hood by itself. So layered design is a technical partitioning. When we are talking about technical partitioning, what does it mean? What we are meaning here? We are meaning that it is divided by layered design, but it's also possible that you will design these services based on domain design. So you can divide it domain partitioning. Here, for example, you will have API facade layers, and each of the and it will communicate with not the layers, but with the components. So one more time, we're now looking into what is inside of this layer. How can you build it? What is the granularity, design granularity of particular service? So another popular design approach is to domain partitioning each domain service using subdomains similar to the modular monolithic architectural style. Yeah, actually, there is a lot of things to say. So regardless of the service design or domain service must contain some sort of API access facade. And the API access facade typically takes on the responsibility of orchestrating the business request from the user interface. Also, we have to keep in mind that because domain services are coarse-grained, regular transactions operation that supports ACID, I mean atomicity, consistency, isolation, and durability of database transaction involving database commits and rollbacks are used to ensure database integrity with single domain service. So high distributed architectures like microservices or on the other hand usually have fine-grained services and use a distributed transaction techniques. Here we have a balance. It means that if you will put some kind of logic and you will successfully divide it, it will not be communicate or you will have less coupling with other services, then it means your chances in transaction in ACID operation is much more higher. Then it means you will deliver the system that will keep data consistency in much more better way than it can be implemented using the microservice architecture. This is one of the painful things when you choose a microservice, and it can be redesigned or solved by this approach. So this is about the granularity. Now, also, actually, it is possible to partition the database. Although, so database coupling can present an issue with respect to database table schema changes. Yeah, we are talking about relational database with table schemas, with non-relational database as Mongo or others. Actually, they will be the similar issues. So a table schema change can potentially impact every service, making database changes a very costly task in terms of effort and coordination. And it can be the issue. So shared libraries might also contain SQL code. And if you will create the single shared library of entity object is at least effective way to implement service-based architecture. And it means any change of database table structures will also require change to a single shared library containing all of the corresponding entity objects. So one of the way to resolve it, to solve this issue is, and this risk is to logically partition the database, not physically, but logically. So it means you'll still have one single database, but logically it will be divided inside. And you can notice in here that, for example, we have here tracking order, invoicing, customer common. Some of them use, for example, this service will use customer entities library, this one invoicing entity, here order entity, tracking entity, but the common entities is used in several services. So you logically split your database. Not there is still physically one database, but each service communicate with separated part of block, separated part. So it means changes in one of them will not affect to others. This is one of the way how can you resolve, how can this issue can be resolved. What is the architecture characteristics rating for them, for this one, service-based architecture? For service-based architecture is a domain partitioning architecture, meaning that their structure is driven by the domain rather than a technical consideration. Fault tolerance and overall application availability also rate higher for service-based architecture because you can replace one service to another one. If something will happen, it can be replaced, so reliability is also better. Deployability is, so let's take a look. Deployability is quite good because it is split into several services, but the number of services is not so high, and still it's quite will be easy to manage changes. Elasticity is a little bit is like 2-star. Fault tolerance, modularity is quite good because you can bring just only another one module. Overall cost is a little bit less than for the layered architecture or microkernel. It means that if it will be a little bit more expensive to implement, and it will cost more efforts from the team to implement this approach. If we will compare with layered and pipe and filter architecture, but still it's quite good, as you can see. Performance is also not so bad. Reliability is good, scalability good, simplicity, testability. So what you can notice that this is like something in the medium that will brings you a lot of average, a lot of points for quality attributes with average values, not so bad, maybe not the maximum. It's not possible to reach the maximum for any architectural styles. Some of them has higher, and one of them is another one has higher rates for another, and based on the quality attributes and quality attributes workshop, when you will prioritize the trade-off between architectural characteristic and what is more important for the project you will apply, and you will choose the most suitable architectural style. This is the key point for your next practicing task, by the way. But here we can noticing that you, if there is no task that okay, we need the system that will cost us cheap, and we need it fast and cheap. Okay, layered architecture, or maybe pipe and filter. Here, the cost will be a little bit more. Simplicity will be not so simple to implement, but from another perspective, we have much more better performance, modularity, overall cost, fault tolerance, deployability. So it means in this way, like if we need to cover also this part, and they are also quite important, like in general, if we'll calculate all of them, we can notice that maybe this is the gold choice, or in the middle, that will cover most of the cases. Yes, it will not be quite simple to implement, but all of the basic characteristics have quite well average values. Yes, it is less for example, as for modularity, or let's say, if we will compare with or scalability, for sure, with microservices has higher scalability rates, but microservices, which will be much more complex and more costly, and you will lose in other things like data consistency and so on. So maybe if we will combine all of the characteristics, that one will be better choice. Actually, that's it for them. So yeah, maybe just, yeah, next will be event-driven architecture style. And we'll take a look at in the next part for the event-driven. Thanks for the attention, and we'll stop here.